Bismillahirrahmanirrahim. Welcome to the third part of this topic of the inequalities, in which that we are going to speak about the absolute value inequalities. We define the inequalities as a mathematical expression in which that one side is greater than or less than the other side. I have two sides, but they are not equal, and that's what we call inequality. It is different from the equality, which means the equation. If they are not equal, we have inequalities. In the last two parts, we gave different examples how to solve the inequalities. We gave linear inequalities and compound inequalities. In this part, we are going to speak about the absolute value inequality. So for any variable expression E and any non-negative real number K, you have to be careful about this part of the statement, non-negative real part or real number. It can be positive or it can be zero. If the absolute value of the expression is less than E, it can be written minus K less than or equal to E less than or equal to K. So if we have less than or equal, then it can be expanded in this way. If the absolute value of the expression is greater than K, then we have this can be true if and only if E is less than or equal to the negative K or E is greater than the positive K. For example, if we have absolute value of X is less than 5, it means X will be between minus 5 and 5. And if the absolute value of X is greater than 7, then X is less than the negative and or X is greater than the positive. If the absolute value of X is greater than 7, then X is less than the negative or X is greater than the positive 7. Let's apply this for different examples. In these examples, we need to use the interval notation to express the solution set of each inequality. I have, in the first example, 2x or absolute value of 2x minus 1 is greater than 4. Since it is greater than, so we are speaking about the second form of the inequality, of the absolute value inequality. I have 2x minus 1 greater than 4. So this can be expanded as 2x minus 1 less than the negative, or you have to be careful about this connection. It is compound inequality now. Or 2x minus 1 is greater than the positive, less than the negative, greater than the positive. You have to be careful about this sign. Now I have two inequalities or compound inequality. I will solve each one separately. So the first one, I will move minus 1 to the other side. Then I will have 2x less than minus 4 plus 1. So it is 2x less than minus 3 divided by the coefficient, which is 2. I will have x is less than minus 3 over 2. So the first one will give me the solution is minus 3 over 2 and less than. Open circle. And less than means go to the left. Now for the second inequality, I will have 2x greater than 4 plus 1, then 2x greater than 5, and x will be greater than 5 over 2. So I have 5 over 2 to the right, and greater than means going to the right. So the solution set will be, for the first part, the interval notation is from minus infinity to minus 3 over 2, and it is open. Second inequality will give me 5 over 2 to infinity. But since we have or, this means the solution will be, or the two interval will be union. So the solution set will be the first interval union the second interval. And we can say in general, if I have a greater than or equal, the solution will take this shape. One part will go to the left and one part will go to the right. And these are in general, if this is not equal to 0, if the number is not equal to 0, these two intervals are disjointed. They are not, or they don't have any overlapping part, or there is no common solution between the two intervals. But since we are using OR, so we have to make it union. The first interval, union the second interval. So this will be the solution set for this absolute value inequality. Let's have another example. Absolute value of x minus 10 greater than or equal to 2. Again, I will have x minus 10 less than or equal to the negative. Less than the negative, or it is x minus 10 greater than the positive. Now solve each one separately. I will have x less than or equal to minus 2 plus 10. That will be x less than or equal to 8. So I will have 8, and that will be less than closed circle, because I have equality there. Go to the left. So the first inequality will give me minus infinity to 8, closed. Second inequality, I will have x greater than 2 plus 10. That will be x greater than 12. So 8, 9, 10, 11, this is 12. Closed circle, because I have equality greater than or equal, and this will go to the right. So the second inequality, this should be 12 there, will give me the interval from 12 to infinity. And again, this is OR. So we must have union. So it is minus infinity to 8 union 12 to infinity. This will give me the solution set for this inequality. For the third example, we have 3x minus 10 less than or equal to. Now this is different from the last two examples. I have less than. This is the first part of the absolute value inequality. In this case, I will have minus 14 less than or equal to 3x minus 10 less than or equal to 14. So the expression will be between the negative and the positive. It is not less than the negative or greater than the positive. No, it will be between the negative and positive. Now to solve this inequality, take the constant to the right and to the left. Change the sign. I will have, it will be 10 minus 14 less than or equal to 3x less than or equal to 14 plus 10. All what we did, we add 10 everywhere. To the left-hand side, middle and right-hand side. So it is like moving minus 10 to the left and right, and change the sign. This will give me 10 minus 4, 14 is equal to minus 4 less than 3x less than 24. Now divide by the coefficient. So we need to divide by 3. I will have minus 4 over 3 less than or equal to x less than or equal to 8. The graph of this inequality, or the solution, will be between minus 4 over 3 and 8 closed circles, because we have this equality, and the solution set will be in between this area or this interval. We can write it in interval notation as close minus 4 over 3 to 8. One more example. Now, if I have absolute value of x minus 5 greater than or equal to 0. Now, the right-hand side is not positive number, it is 0. But we are going to apply the same concept. Since we have greater than or equal, so I will have x minus 5 less than 0 or negative, or I can say minus 0, but we don't have minus 0. Just I will write it just to make it clear. Or x minus 5 is greater than 0. So if I just remove this one, it is either less than or equal to 0 or greater than 0. It means x will be less than 5 or x greater than or equal to 5. X is less than or equal to 5 or x greater than or equal to 5. So it will take at 5, either x will be less than or greater than. So this is from minus infinity to 5, union 5 to infinity. Or I just can write it as minus infinity to infinity because 5 is included in the two intervals. This is because the right-hand side is 0. So the solution set will be from minus infinity to infinity. One more example, if I have 2x plus 7 less than or equal to 0. We know that the absolute value is always positive, so it can't be less than 0. So the only possible for this one, that it will be when it is equal to 0. This is 2x plus 7 equal to 0. This is the only solution for this one because it is less than or equal. It can't be negative because I have absolute value. Absolute value is always a positive quantity. So if it is less than 0, it can't be. So the only option for this one when it is equal to 0. So I have equation in this case, I will have 2x plus 7 equal to 0, then x equal to, or 2x equal to minus 7. This will give me x equal to minus 7 over 2. So the only solution for this one, it is minus 7 over 2. It has a single value solution equal to minus 7 over 2. But just to make it clear, if I apply the formula, it will be between 0 less than 2x plus 7 less than 0. Or I can say minus 0 and 0, just to make it clear. We don't have minus 0, but it will be between 0 and 0, which is equal to 0. So the only solution for this one when x equal to minus 7 over 2. So this is how to solve absolute value inequalities. If it is greater than, so it will be less than the negative, bigger than the positive. If it is less than k, it will be between minus k and plus k. It will be restricted between negative and positive.